So we are going to start the chapter that is called the periodic tables. In this chapter, we would be discussing, like you can say that, the introduction of different elements, and also like the definition of periodic table, and how the elements are arranged in the periodic table, and what is the base, like you can say that the what are the bases of arrangements, how we did like all the elements in specific order, like in groups and periods and like all that stuff. So we would be discussing just like that. And if you can see, this is the periodic table,
Mhm.
and all the elements are arranged in a particular order. Like I can say that these are metals, non-metal, non-metal gases, and these are the transition metals basically. So it's the arrangement of different elements that is known as periodic table. So, and also we, like, precisely if I discuss, we have metals in the periodic table, we have non-metals in the periodic table, we have metalloids in the periodic table. So arrangement of elements in groups, I mean to say in columns, and in periods, I mean to say in rows. So as if you can see, this is a row, first row, then we have second, then third, then fourth, then fifth, then sixth, then seventh. These are rows. And first column, second column, third column, fourth, fifth, sixth, seventh, eighth. So the columns, so the column is called group. This is a group. And this is called the period. This is called the period, like a row. This is called row. That is
Okay.
period. So it's a tabular arrangement basically. Periodic table is a tabular arrangement of elements in groups and periods, in rows and columns. In groups and periods and rows and columns is called periodic table. And you can say that the basis of arrangement of different elements, you can say it's a proton number. It's a proton number. It's a proton number, right? Proton number means that this is hydrogen, this is 1, then this is 2, then this is 3, then this is 4, then this is 5, 6, 7, 8, 9, and 10. So as the number increases, it's in increasing order. It's in increasing order. We have arranged all the elements in increasing order. This is 1, that's why this is on the top. This is 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, then so on. Like all of the elements are arranged in this manner. So the basis of arrangement is the proton number. In total, there are 8 groups and 7 periods in the periodic table. Okay, there are 8 groups and 7 periods in the periodic table, right? And if you can see the colors, this is a metal. So these all are metals. All are metals. And if you can see, this is a non-metal. Okay, non-metal, and
Mm-hmm.
they are metalloids. They are metalloids on the stairs, up and below the stairs. This is boron, silicon, this is germanium, this is arsenic, this is antimony, and this is tellurium, and this is astatine. These are metalloids. Okay, so now you can easily address which element is having like the what category. This is a metal and this is a non-metal, including this. These are also non-metals, but they are inert gases, so we would be discussing separately. This is, you can say that the group 8 is the special one, in which all the elements are not going to react with anything else because their outer shell is complete. We would be discussing in later. So, and then starting from, you can say that, what is group? What is group basically? Group means vertical column. Group means vertical column. Group means vertical column in the periodic table, like top to bottom. Group means vertical column in the periodic table from top to bottom. From top to bottom. Okay, like I mean to say that from top to bottom, top to bottom, top to bottom, top to bottom, 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 top to bottom, just like that. So they
Okay.
are groups. They are groups. If you count in modern periodic table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I can say that 18 groups, or exclusively you can say that excluding this, excluding this, excluding transition metals. If you can count, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So total 8 groups in the periodic table. Okay, so vertical column in the periodic table is called group, like talking about top to bottom. Group number indicates the number of valence electrons. Group number indicates the number of valence electrons. Basically, this is the characteristic of a group. If you know the group number, so what is the benefit of that? So you can say that the group number is going to tell you the total number of outer electrons. If you remember, we have discussed electronic structure, electronic configuration in, you can say, atomic structure. So if I ask chlorine, whose proton number is 17, can you tell me how many shells would be in chlorine and how many outer electrons are there in chlorine? Can you tell me? Yes?
There will be 3 shells,
Yes?
and there would be 17 electrons.
Okay. Your
Yeah,
camera is blinking, I think so. Your camera is
right?
blinking. It's blinking.
It is.
It's, yes, now this good. No, again, this is off. Yes.
Um,
Now, yes. I can see this. Okay. Okay. So you were saying that chlorine, first of all, 2 electrons, then 8 electrons, then 7 electrons.
yeah.
Are you getting me? Yes, good. So I can say that the group number is 7 for chlorine. The group number is 7 for chlorine. Why? Why? Because its outer shell contain 7 electrons. If you can cross check from the periodic table, so you will see that this is chlorine. This is chlorine. So
Is it always the
chlorine
last number?
is
It's
in
always
group
the
7.
last number. Is it
Yes,
the
exactly.
shell? Okay.
Only the last shell electrons. Only the last shell electrons, which are also known as outer electrons, which are also known as valence electrons. Outer electrons, valence electrons. Okay. So if you know the group number, you can say the outer electrons. And if you know the outer electron, so you can predict the group number. Let's suppose randomly I am giving you the configuration, I'm giving you the atomic structure, like electronic structure of X, I don't know what is this, just I know that the proton number is 19. The proton number is 19. So I'm asking the group number. Okay. So you will draw the configuration. In the first shell, I have 2 electrons. In the second shell, I have 8 electrons. And in the third shell, I have 8 electrons. Again, how many electrons are remaining? Yes.
One.
1. So this is 1. It indicates that X is in group X is
One.
in group 1, exactly, because it contains one electron in its outer shell. So that's what I'm telling you. Group number is going to tell you the group number is going to tell you the outer electrons, and I can say that alternatively, that if you know the outer electrons, it's 1, 2, 3, it may be 2, it may be 3, it may be 4, it may be 5, means that you can predict the group number. Are you getting my point?
Yeah.
Okay, so sodium is in group 1 as it has one valence electron, and then aluminum is in group 3 as you know that aluminium contains 3 electrons in its outer shell. Okay.
Okay. Okay. Yeah.
Okay. Then we have relationship between the group number and charge. This is very important. When we would be discussing the formula formation, then I would be telling you it would help you a lot. Right now, I can say that something which is in group 1, they would be having +1 charge. Those elements which are in group 2, they would be having +2 charge. Then this, then this, then this, then this, then this, then this. So let me apply this. This is aluminium oxide. This is aluminium oxide. Aluminium is Al. Oxide is oxygen. Can you tell me in which group aluminium is? Yes.
Aluminium is. Wait. What? What's the proton number of aluminium?
No, I'm just asking, see aluminium, see the periodic table and just tell me in which
Oh.
group aluminium is.
Uh. 13.
Uh, it's in group 3, right? It's in group 3, or
Yeah.
you can say it's in group 13.
Yeah.
So, yes, so something which is in group 3, something which is in group 3. So, what's the charge? What's the charge?
Um. 3.
Exactly. I'm going to write 3 over here. And this is oxygen. Can you tell me the group number of oxygen? In which group the oxygen is?
Oxygen is in group. Um. Wait. Sorry. Oops. 8.
Okay, this is 8. No, it's not 8. It's not
Oh
8.
wait, no. Sorry, I was looking at the. It's in group. It's in group. Uh, 5. 5, I think.
No,
6.
yes, 6. Oxygen is in group 6. So those elements which are in group 6, what's the charge?
Um. Group 6 will be -2.
Like I'm going to write 2 over here. Just ignore the charges because in the formula we are not supposed to write down the charge. So to make this compound, I'm supposed to alternate these numbers just like that.
Isn't it -2?
Yes.
So
So
why
this
is
is
there
the formula. In
no? But
any
why?
chemical formula, basically, we are supposed to put the valency, put the numbers, not the charge. You never saw any formula with the charges. Like in any formula, you will see, like you can say -2, -3, +1, +1. We
Wait.
are
So
not
why did
supposed to
you put?
mention
Wait.
the charge
Why did you put 2 for oxygen?
because this is in group 6. Something which is in group 6.
Has
So they
negative
are
2.
having exactly. So I'm saying that just ignore the charge, just ignore the sign, just put the
Oh,
value that is 2. Same goes with aluminum. I have put only 3. I didn't put any, like you can say that plus 3. Just ignore the charges and just put the number, and then just look at the formula, and then just look at the
okay.
formula. Okay, so then just look at the formula. So the formula is Al2O3. This is the benefit of the charge. This is the benefit of the valency, which we have. You can say that just I wrote just looking at the group number. Group 1 means plus 1, group 2 plus 2, group 3 plus 3, group 4 4, group 5 minus 3, then minus 2, then minus 1, and then 0. Okay, are you getting my point?
Yeah.
Good. And then can you tell me the formula of can you tell me the formula of magnesium oxide?
Magnesium oxide. Um. Okay, wait. One, two, three. Okay, so magnesium is in group 2,
Okay,
so B2, and oxygen is in 8. It's 6, I mean 6. So it will be, yeah, it will be in, so it will be Mg2 and O6.
so something which is in group 6, what's the charge?
2.
Exactly, this should be 2. They
Yeah.
are the same numbers. They are the same numbers. I can cancel the numbers. So the formula is MgO. So this is the formula. Are you getting my point?
Oh, okay.
Exactly. So that's the thing that I want to tell you, that if you know the group number, then you know the charge. If you know the charge, then you can write down the chemical formula. Okay?
Okay.
Okay, this is the last one. Carbon dioxide.
Carbon is in group 4,
Yes.
and dioxide is oxygen is in group 6. So the 4 will be 4, and it will be 2. So 4 and 2. Then you swap it, so it will be C2O4.
So it can be simplified.
C1O2.
This is why
CO.
the formula is CO2.
Oh, okay.
Exactly. This is why the formula is carbon dioxide like the CO2.
Okay.
Yes. Okay. So this is the charge, and we can tell the formula of any compound by looking at the group number. So, okay. Then remember, we have particularly, exclusively different groups which are special. We give the special concentration to that groups. The first one is called alkali metals. The first one is called alkali metals, then alkaline earth metals. Then we have halogens. Then we have noble gases. These are the special groups. We would be discussing one by one. We would be discussing one by one, right? And then uh, let's suppose in any element, okay, you can say that Okay. Elements which have the same chemical properties. Let's suppose we have lithium, we have sodium, we have potassium, we have rubidium, we have cesium, we have francium. I'm talking about group one. I'm talking about group one. I'm talking about group one, just like that. This is lithium, then this is sodium, then this is potassium. It's a group one. So all the elements are having the same chemical properties. If I ask why, you can say that they all are having only one valence electrons. Am I right? Am I right?
Yeah.
They all
Yeah.
have one valence electrons. Remember, when we were discussing isotopes, then I told you at that time why the isotopes are having the same chemical properties. Why the isotopes are having the same chemical properties? Because their electrons are same. So electrons are responsible for the chemical reaction, for the chemical property. Electrons are responsible. When the electrons are same, so the chemical property is same. When electrons are different, so chemical properties are different. As you know that in a group all the elements are having the same number of outer electrons, one. So I can say that their chemical properties are same. This is also the characteristic of group. After saying that, they have you can say they can tell the outer electrons. This is also a characteristic of a group, that if you know the group number, it means that you can tell the outer electrons. And then elements have same chemical properties because they have the same valence electrons, because they have the same outer electron. Okay, are you getting my point?
Yeah.
Okay. Then we have period number. So period means horizontal rows in the periodic table from left to right. Horizontal row means from left to right. Horizontal row from left to right is a period. Like, see this horizontal row. Horizontal row. This is one, this two, three, four, five, six, seven. These are horizontal rows from left to right is a period. Same as the group. So obviously the period would be having some characteristics, obviously. So we generally, you can say, period number is going to tell you the total number of shells. Period number is going to tell you the total number of shells. Okay, let's suppose, um, let's suppose if you can see this, this is second period, this is third period, this is fourth period, this is the fifth, this is sixth, and this is seventh. Okay, as you know that the proton number for lithium is 3, if you are going to write down the electronic structure, if you are going to write down the electronic structure for lithium, can you tell me how many shells you would be having? How many shells you would be drawing for lithium? Yes?
Uh, you be drawing. Is wait is for wait yeah it's two and the two shells I think
2 shells. In the first shell, how many electrons?
two
And in the second shell?
one
1. Exactly. Without drawing the structure, without drawing electronic structure, without writing electronic configuration, you can predict the total number of shells by just looking at the period number. If this is in period 2, it's mean that if you will draw the structure of lithium, you will see 2 shells. If you will draw the structure for beryllium, you will see the 2 shells. If you will draw the structure for boron, you will see the 2 shells. When you will draw the structure for carbon, you will see the 2 shells. 2 shells, 2 shells, 2 shells. Why? They are in the same period. They are in the same period. And period number is going to tell you the total number of shells. And if you talk about potassium, if you talk about potassium, potassium is 19. It's 19. If you are going to draw the electronic structure, if you are going to write down the electronic configuration for this potassium, obviously potassium is in period 4. Potassium is in period 4. Period 4 means that when you will draw the structure for potassium, so you will see 4 shells. You will see 4 shells. 4, 4, 4,
Yeah.
4, 4. Exactly, because the period number is 4. Because the period number is 4. So this is the characteristic of period. Just like group, I told you the group number is going to tell you the total number of outer electrons. So this is going to tell you the total number of shells basically. This is going to tell you the total number of shells basically. So do not
Okay.
need to write down the electronic configuration, no need to draw the electronic structure, but you can predict the group number, you can predict the outer electrons, and you can predict the, you can say the total shells. So it's
Okay.
going to tell you the period number. Period number is 3, means 3 shells. Period number 4 means 4 shells. Period number 5 means 5 shells.
Okay.
Okay, yes. So, um, if you see this periodic table, in this table, as we are going from left to right, just like that, starting from Na, then Mg, then Al, Si, P, S, Cl. As you go from left to right, metallic structure, metallic strength decreases. On your left hand side, you have metal. On your right hand side, you have non-metal. So the solidity is going to decrease and the metallic character is going to decrease, because as you are approaching to the left hand to the right hand side, obviously you will be going far away from the, you can say, the metallic behavior. So when you are going from left to right, just like that, so you are leaving metals, leaving, and approaching. From left to right, the metallic character decreases. From, okay, metallic
Okay.
character increases. Metallic character increases across the period. Sorry, metallic character decreases. These are metals, these are metals, and these are non-metals basically. Okay.
Okay.
Yes. Now we can summarize it. This is your first structure.
Uh,
Let's suppose, okay, so this is the first shell having 2 electrons. This is the second shell,
8.
and this is element X. I have to tell the group number and the period number. Yes, can you tell me? I want to ask. I want to see the group number and period number. Yes,
So period. So the group number will be 1 plus 2. It's all on the outer shell, so it will be 5.
exactly. So the group number is 5. So the
And the
group
period
number is 5. Yes,
and the period number is 3.
exactly. The period number is 3. The group number is 5 and the period number is 3. So this is also the advantage of electronic structure, that after counting the total shells, after having the outer electrons, the valence electrons, then you would be able to tell the group number and the period number. Are you getting my
Mm.
point?
Yeah.
Yes. Okay. Then we have electronic configuration, like we did in the atomic structure, electronic configuration, right?
Yeah.
So Okay. So first of all, we would be discussing group one. First of all, we would be discussing group one. Group one are known as alkali metals. Alkali metals, as they react, as they react, okay, like they are reactive metals. First of all, they are reactive metals, and um, they are soft. They are having low melting point and boiling point. They have a low density, okay, and you can say they have a low density, and they do not form colored compound. Their compounds would be white, colorless, or okay. So as you know that you have other metals as well, like iron, like copper, like gold, like nickel, like all of the things. All metals are hard, but they are soft. They have some special characteristic. They have some quite, you can say that the unique properties as compared to the other metals. They are soft. Other metals are hard. They have low melting point. Other metals are having high melting point. Okay, so these are the simple, you can say, minute differences between them. So group 1 elements means that they are the elements which are present in group 1. So I can say that they would be having only one outer electrons. Like if you talk about lithium, then sodium, then potassium, then rubidium, then cesium. Okay,
Okay.
so they would be having one valence electron. As the group number indicates, if you know the group number, it means that you know the period number. Okay, if you
Okay.
know the group number, just after looking at the outer electron, it's mean that, uh, and also after looking at the total number of shells, you can identify the, you can say, you can identify the period number. Okay, this is very
Oh,
easy. I think so. This is
yeah.
very easy.
Okay.
Yes.